Welcome to our webinar today on technologies to reduce the use of mercury in artisanal and small-scale gold mining. This is the latest in our series with the World Bank in support of the Environmental Health and Pollution Management Program. We have a good series of speakers, presenters, and discussants, and we also hope for some time for question and answers. So thank you all from Unitar, and then I would like to hand over to my colleague Frank from the World Bank, who will do some opening remarks to lead us in. Frank, over to you, please.
Great, thanks so much, Oliver. This is really a great opportunity. I see we have a lot of people connected, which is very encouraging. I just want to give everybody a warm welcome for joining us at this webinar. We're going to be having two webinars, another one on April 15th. I'm already giving a heads up as well. But this one is specifically on the mercury and how to reduce the use of mercury in artisanal and small scale gold mining. We've been working on this through the what's called the World Bank's Africa Environmental Health and Pollution Management Program. This is a series with Unitar is part of that regional view that we're trying to give to this issue. We've worked in several pilot countries thanks to Global Environment Facility funding. This is an important focus for the World Bank. We know that this is a very significant challenge across sub-Saharan Africa. Given the importance of gold mining in many of the countries in the region and the increasing importance of it in the last few years. But it's not the only issue. We're also looking closely at issues such as exposure to particulate matter, which in 2019 we estimated is may be responsible for over 900,000 premature deaths. We also are calculating, the World Bank has calculated that health-related economic costs are around 6% of the region's GDP. So this is something that we're very closely looking at. The country, the continent is becoming more urbanized over the next decades. So these are areas that we're very much interested in supporting countries, and hopefully this webinar will help that. In particular, on the mining side, there's been a tremendous increase in mining across the world. I'm coming from Latin America, where lithium, copper, many other types of mining, gold mining, is also increasing. So there's actually space for global sharing, and there are many projects that are focusing on this, and our colleagues from the UN system and other projects are also looking at Latin America. I cover Southern and Eastern Africa, but this project has been looking at countries in Eastern and Western Sub-Saharan Africa. And we're looking a lot at the health effects that come with mercury exposure that can particularly affect vulnerable populations. Sub-Saharan Africa has a tremendous young population that are going to be coming into the workforce as well. But we're very concerned about all of the exposure that pregnant women, children, and infants are having now because of these different industries and artisanal industries that can lead to neurological disorders, cardiovascular disease, and developmental delays that will have a real economic effect on the continent at an important scale, considering the many people involved in this industry and the use of mercury in gold mining. So this requires a multifaceted approach that involves regulatory measures, technology, awareness raising, and also international collaboration, which is where we come into this. And this is part of that awareness raising aspect of the whole equation on approaching this issue. So it's the main contributor. This issue of artisanal small-scale gold mining is the main contributor to global mercury emissions right now. The miners, extract gold in large quantities, and this goes into the atmosphere and the water bodies and environment in general. Many of you, connected already know these, but it's important to keep reaffirming. And there are estimates of up to 2,200 metric tons per year going into the environment. And of course, these are substances that at a very small amounts are very significant in terms of the health. And the small scale artisanal mining accounts for about 850 metric tons of that. So a significant 40% is coming from this sector in terms of the mercury emissions each year. So this is what the convention, the Minamata convention is looking at, and hopefully each state that's party to the convention, and we have many a good part of the states in the region are parties to the convention. So the idea is that they take where they can and feasible measures to eliminate mercury and mercury compounds. So part of the work that we've been doing with the program over the last few years with the pilots that we've done, for example, in Ghana, we've been working as well as Kenya, Senegal, Tanzania, and Zambia. So we have some interesting data and things that are coming out of all this work. The in Ghana, for example, the initial Minamata assessment in 2018 has indicated that an estimated 1 million people working in ASGM, as it's called, out of a population of 28 million, so it's about 3.5% of the population. Kenya, all the countries are showing also with the increase in the prices of gold. All of our colleagues are indicating to us in the countries that there are more people attracted to these sectors. And Kenya, for example, has shown that this small-scale mining can be more attractive financially than farming, so it's pulling away people from that sector. Also, that impacts food security in communities, as well as the toxic legacy that's left. So in Senegal also, we have community engagement is helped in the use of alternative technologies. So the idea is that we're trying to reduce the exposure to mercury vapor in the technique. So technology, and trying to find some technology that's appropriate for our countries in the Africa, sub-Saharan African region is important. So this allows the technologies allow us to recapture, for example, mercury. So if they're going to be involved in this, are there ways of doing this that will help to recapture the mercury and not expose the environment and people to the toxic effects of it? In Tanzania, we're seeing that the field surveys have observed that in about 1 out of every 6 working children, or about 17%, are in contact with mercury. The general observations are that none of them were taking any protective measures and unaware of the adverse health effects. This is a big issue. Zambia, where also we're working, targets have been established to increase the formalization of these small scale miners, to try to support their improved working conditions. And so hopefully they're going to go from the 2% of miners covered to at least 50% of the miners to support them in terms of improved working conditions by 2030. So some of the things that can be done in these countries have been mentioned already: the capacity building, working with international organizations and NGOs. We are trying to we're talking a lot in the multilateral organizations of how to bring things to scale. We're trying to leverage, the government's investments, as mining is very important. If there are important mining investments, to also look at these smaller scale miners as part of an overall sector strategy. So hopefully, with both capacity building and policies in the countries that are also followed by investments, that can help miners move to alternative technologies that can reduce the use of mercury in gold mining. These can include things like there's some specialized techniques called gravity concentration, looking at cyanide leaching, borax method, magnetic separation, and chlorination, among several other techniques. All of them you can hear also use some chemicals that require certain level of understanding on how to manage these systems. So there are no perfect non-toxic and easy solutions, but the importance is that we bring with the alternative technologies the capacity building. These are technologies that are less that are more efficient, more environmentally friendly, do have their requirements, but through a strong capacity building and constant support and scaling up by governments, because they can really do that scaling up that NGOs and multilaterals can't do just directly. It really has to be mainstreamed into what governments do. And also we need to work on more research and monitoring, know where the problems are, where the issues are. Every different region in Africa and every country has different realities in terms of policies and the interventions that are needed. And then again, the other issue is community engagement. I mean, these small scale activities have a whole ecosystem of people and services and communities that are exposed directly or indirectly, that really need to be part of the solution. So hopefully this all of these aspects will be, continuing to support in the coming years with all of you that are engaged here. I see this large audience is, I'm sure, part of this process, hopefully. So, there are no short-term solutions, but today we'll look into these issues a little bit more, and hopefully this will inspire you and pique your creativity and really help us in this multi-pronged, multifaceted approach that we need to bring forth. So today we'll have presentations from Mr. Eric Negulic, Unitar ASGM expert, who will present an introduction to mining, ASGM, and why mercury is used, and explanations on alternative methods and options for reducing mercury use. Then we'll have Mr. Dominic Bali Kipkro, Research Fellow at University of Wollongong, Australia, and Executive Director of the African Centre for Environmental Health in Côte d'Ivoire, who will update us on practical work and studies on ASGM and alternatives to use of mercury, as well as formalization. And Stefan Bose is also here, who's an expert on the aspects of health and mercury and the impacts of it. So we look forward to hearing more from our presenters and discussants today. And I, again, hope you enjoy and learn, and welcome and thank you for listening to me today. And we'll be enjoying, I hope, these presentations. Over to you, Oliver.
Thank you very much, Frank, for that intro. To just try and make up for a bit of time that we lost at the beginning, we will just move on quickly. So over to you, Eric, to present and then lead us through the next few sessions. And just to acknowledge, apologies about the interpretation. We're still trying to work in the background to get that working for those who would like to follow it in French. So apologies again. We'll do what we can. And over to you, Eric. Thank you.
Okay, great. Thank you. Thank you very much, Frank, for setting the stage here and for that background information. I hope everyone can see my screen now. As Frank mentioned, I'm going to start with an introduction to artisanal and small-scale gold mining. As Frank mentioned, I work with Unitar as a consultant. I've been working in artisanal and small-scale gold mining for over 10 years now. I've worked throughout West Africa and Latin and Central America, and I've been really fortunate to have spent quite a bit of time in the field, which is, I think, really grounded me in the realities that we see and face in addressing mercury use. So I'll move on here to my next slide. Okay, so I'll talk a bit about what is artisanal mining today. I'll give a background on geology and the importance of geology in artisanal mining. I'll look at mineral processing and how it's done using mercury, and as well considering mercury reduction alternatives and processes to reduce mercury use. And I'll look as well at some local and regional models of mercury reduction and the organization of the artisanal sector in processing workflows. So artisanal and small-scale gold mining means gold mining conducted by individual miners or small enterprises with limited capital investment in production. That's the definition from the Minamatic Convention. It's typically manual or semi-mechanized techniques in relatively small groups, generally informal. And of course, as we heard from Frank, there are health and environmental risks associated with this, particularly around mercury use. But there are benefits as well. Artisanal mining is a great way to directly inject money into remote and rural parts of countries, and it's an important part of the livelihoods of millions of people around the world. So we want to try and support it while reducing the negative aspects associated with health and environment. Key concept is that every ASGM site is different. On this slide, I've shown a range of pictures from West Africa and Latin America. The top row is Senegal and Burkina Faso, showing a range of different extraction sites. And then the bottom includes a site in Suriname, Sierra Leone, as well as in Nicaragua. So the key here is that we need to tailor solutions for the sites that we're seeing, and that every set of ore and every mine site has its own challenges. So I'll very quickly go over some key concepts of geology. I know we have a diverse range of attendees, so we're all familiar with rocks. Rocks are composed of minerals. So this middle picture is, it's showing the white, black, and sort of pink colors. Those are different minerals in the rock granite. And then in some cases, gold can occur as a mineral. Gold is an element, but it can also be found as a mineral within the matrix of the rocks. Another important concept is ore grade. So in this top figure here, I've shown on the left a lower grade ore, so the gold dots represent gold, and on the right, a higher grade ore. So grade really just means the concentration of gold in the ore that we are processing. It can range hugely. Artisanal miners target higher grade deposits than large scale miners, and it's expressed in grams per ton for the most part. Purity is another important concept. The metal that comes out of the rocks, it is gold, but it's not pure gold. It's typically an alloy of gold, other metals, including copper or silver. So the purity refers to the total percentage of actual elemental gold in that recovered metal. There's a few different types of mineral deposits, generally classified into two large groups, being hard rock or soft rock deposits. Hard rock deposits are just that. They're hard solidified rocks that need to be broken apart to separate the gold. Soft rock deposits are typically sediments. They've been weathered and eroded and deposited in a new location. And in that process, gold can be concentrated and found in those sediments. Again, the key here is that there can be significant local and regional variation in the type of gold-bearing deposits. So when we're addressing this and developing processing workflows, we really need to keep in mind what those are and design the systems for the ore that we're processing. So a very common gold processing workflow for hard rock deposits, at least, is to first extract the ore from the ground, so to mine it, to then crush it to reduce the grain size from large rocks that come out of the mine to a smaller gravel. From there, that gravel is then milled, further reducing the grain size from a gravel down to a sand, at which point we can then look at recovering the gold from the sand. There are common ways to do this in artisanal mining. The most common is mercury amalgamation, and as well in some cases gravimetric concentration, as Frank mentioned in the introduction. I'll talk about both of these more on upcoming slides. In large scale mining, and in some cases and applicable to sort of smaller scale as well, are chemical processes such as flotation or cyanide leaching, which I'll also talk a bit more about in later slides. Another important concept to understand when considering recovery of gold from ore is grain size control and liberation. So this figure in the top left is really just showing how we separate the minerals in the ore. So the first picture shows a matrix of different black and white minerals with some gold represented in yellow in there. It's broken down to try and liberate that gold. So the grain size is reduced from large chunks to smaller chunks. You'll see in the middle that there are still minerals stuck together. And then in the third one on the right, you start to get that separation into sands where the individual minerals are on their own. They're no longer connected to other minerals. This concept of separating the minerals and the gold from those minerals is referred to as liberation. And it's really, really important in recovery. So for all types of recovery, gravimetric concentration, mercury amalgamation, if we don't have that liberation, then you're not going to get successful recovery of the gold. One last important concept here is the concept of concentration. So if we look at the total volume of ore, let's say we have 1,000 kilograms, 1 ton of material that we're looking to process, there's maybe 20 grams of gold in that. So 20 grams per 1 ton, 1,000 kilograms is a very, very low ratio. We can remove some of the lighter materials to increase that concentration. You could potentially bring that from 1,000 kilograms of material down to 1 kilogram of material without losing much of the gold. So you would then have 20 grams per 1 kilogram instead of 20 grams per 1,000. That concentration step is very important in mineral processing, and it separates the material into the concentrates, the high-grade sands containing the gold, and the tailings, the rest of the waste material that hopefully at this point doesn't have much gold left in it. Again, the process of liberation is really important. In gravimetric concentration, gold weighs a lot more than the other minerals in the ore. Gold weighs over 19 grams per centimeter cubed. It's got a very high density. Quartz, the most common mineral in most ores, weighs about 2.65 grams per centimeter cubed. So gold is over 7 times heavier than the most common minerals in the ore. Because of this, we can use gravity to help us separate the gold from those other minerals. It's a common practice, and it's applied in artisanal mining and large-scale operations in some cases around the world. Mercury amalgamation, I'll talk more about in the next slide. Any unliberated gold will not be successfully concentrated using mercury either. So back to that idea of liberation, we really need to get that complete separation of gold from other minerals. To ensure we get this, grain size control is an important concept. And it refers to making sure that we understand the size of the gold and that we separate the sands down to that size so that we really get that true separation. Okay, I'll now talk a bit about mercury use in artisanal mining. So that common process of crushing and milling to separate it down to a sand is then often followed by amalgamation with mercury. So how this works is the sands that are recovered from that are
Hello, Eric, are you there? Hello, Eric. Sorry, colleagues. I'll just try to see what's happened there.
Hello, everyone.
Okay.
Sorry, can you hear me now?
Yes, we can.
Yeah, I'm not sure what happened. I lost my microphone and video there, so I had to rejoin. I'll share my screen again and get this presentation going. Sorry about that.
It's okay.
Okay. So I think I was about at mercury amalgamation when I dropped there. So I'll carry on from there. So mercury amalgamation refers to when we add mercury to the sands that have been separated at the ore that's been broken down to a sand. This is done in a basin usually with water, and mercury is very heavy. It with gold settles to the bottom of the basin. The mercury essentially dissolves the gold, and then the light materials can be washed away with the water, leaving behind this liquid mercury containing the gold. That gold mercury mixture can then be recovered. It is squeezed through a cloth to remove the excess mercury, leaving behind a ball of mercury and gold amalgam. That amalgam is then treated by heating it in a furnace or with a blowtorch or over a flame to evaporate the mercury, leaving behind just this sponge gold. It's a ball of gold that looks like a sponge that can then be smelted and refined to improve and increase the purity. In this process, of course, mercury is lost. There's loss to the tailings, to the sands, as well as into the water that's used to amalgamate it. And then it's also lost to the air during the burning. The amount that's lost to the air can be reduced using tools such as retorts or fume hoods, but there is always some loss to the atmosphere. I'll talk a bit more about the amalgamation process. There's two ways to do this. It can be done by amalgamating all of the ore that comes out of the mine. That's called whole ore amalgamation, or it can be done by amalgamating a concentrate. So a gravimetric concentrate, a reduced total volume, can then be amalgamated. The amount of mercury, depending on which of these processes is used, varies quite largely. Whole ore amalgamation, there's more material to treat, so more mercury is added, means more mercury is lost. We use a concept called the mercury to gold ratio, looking at for every gram of gold produced, how many grams of mercury are lost to produce it. For whole ore amalgamation, it can be above 10 to 1. So for every gram of gold produced, 10 plus grams of mercury may be lost, which is quite a lot. Concentrate amalgamation is much better. It can be as low as about 1.3 grams of mercury to 1 gram of gold. And in the case of retorts or fume hoods, it can actually sometimes be brought below 1 to 1. So there are better practices in mercury use that can be applied in some cases. Okay, I'll keep going here. I'll talk now a bit about some alternatives. So gravimetric concentration, as we heard, is a useful opportunity to produce gold without using mercury, or at least to develop concentrates that can be used to reduce mercury use. Here are a bunch of photos of different types of gravimetric systems. The first one being a simple pan where water is mixed around with the sediments containing gold to remove the lighter materials, creating a gold concentrate. The next is a sluice box. It's an inclined box that has carpets on it. Water and the sands are run over that box, and the gold, being heavy, gets captured in the fibers of the carpets that can then be washed to recover the gold. Shaking tables in the top right are tables with ridges on them that vibrate. With the slurry, the mix of sediment, of gold-bearing sediment and water, are run over those. The gold, being heavy, gets stuck in the ridges, and the light materials are washed off, allowing us to concentrate the gold. In the bottom left is a cone concentrator. It's a spiral concentrator system where there is a spiral in the middle of that cone. The cone is spun in a circle, and water is flowed through the cone. The gold is stuck in the ridges of the spiral and brought to one end while the water is washed out the other end. In the bottom middle, there is a centrifuge. This is an Icon centrifuge concentrator where centrifugal force, it's spun in a circle, separates the gold again based on the difference in weight. And then the bottom right is a vortex type concentrator where water is spun around in this bowl in a circle. The light material is suspended in the water and separated through the middle of the bowl, and the heavy materials, the golds and other heavy minerals, remains in the bottom. So no one of these systems on its own is necessarily going to treat ore to the point where we can smelt it directly, but in many cases you can get to a point where you have a high grade concentrate that can be smelted directly without the need for further chemical processing, if you design a system that goes through a few of these different steps to continually increase the concentration. Other approaches are chemical treatment methods. Flotation is common in larger scale operations. In this case, chemicals are added to the ore slurry to make gold hydrophobic to repel water. Air is injected into the cells, and then the gold attaches to those air bubbles and floats to the surface, where it can be skimmed off as a concentrate for further processing. This can work well for some types of ores, particularly sulfide-rich ones, which are difficult to concentrate gravimetrically. However, there are challenges for ASGM, being the high costs of these systems, more so than gravimetric systems, chemical handling and storage, and generally the scale of these is quite large compared to the sort of smaller scale gravimetric systems that we can use. Cyanidation is another option, so leaching approaches to treatment, where chemicals such as cyanide are used to dissolve the gold in the sands. That dissolved gold from the solution is recovered using an activated carbon or zinc precipitation method to get the gold back. These are great for larger scale operations. They're very high recoveries. So gravimetric concentration can get up to about 70% of the gold in a good case. Flotation can get above 90%, and cyanidation can get up to 99.5 and above percentage of the gold. So very high recovery, good for lots of different types of ore, but also quite expensive, and the scale is larger, and you do need skilled operators and proper chemical management for these systems. So some key considerations when designing workflows are the characteristics of the ore. We need to really understand what we're working with to be able to design a system that's going to successfully capture the gold. We need to know the throughput, so how much ore are we looking to process in a day, and what's the capacity of production of the miners we're working with. What's the technical capacity of the team to process this? Do we need to bring in outside experts, or the system something that could be operated by the workers in site? Training requirements, of course. Budget, so what is the funding available for these? And then can they be maintained? We need to make sure that any system we put in place can last, can endure, and it's not gonna fall apart, and we're not gonna have issues accessing parts. So I'm going to spend the last few minutes here of my presentation looking at different configurations of processing systems and models and how the ASGM sector is structured. So the first one is very common, where miners process their own ore. They extract it from the site, and then they either process it using pans or using sluice boxes in combination, often with mercury amalgamation. It's low cost, it's fast, it's done on site. They don't have to deal with anyone else, so there's no trust issues. However, these systems are fairly rudimentary. It's poor gold recovery, typically 30 to 50% of the gold in the ore. It's informal, and if mercury is used, there's of course that health and environmental risk, and there's no tailings management. The tailings are typically left on the side of the mine site. Another option, which is quite common, I've seen this a lot when I was working in West Africa, is local fee-for-service, where you have local processing systems that the miners bring their ore to, and then they pay a fee for that service. It often uses tools like disc mills to crush and grind, sluices to concentrate, and then mercury amalgamation to finally recover the gold. It's cheap, it's available, there's no trust issues because they pay a fee and they can watch the processors process their ore, but it's rudimentary for the most part, and it commonly uses mercury amalgamation and still recovers very low amounts of gold. Another option that's been growing in popularity is centralized processing systems, where a larger scale plant, a cyanidation plant potentially, or a flotation cell, or a combination of various systems is available to treat the ore. Typically, in these cases, miners sell all of their ore to the system to be processed. It's great because it's large scale, can process higher volumes. It's industrial, so it's typically permitted and regulated, and there's sort of health and environmental safeguards in place. The downsides are that these are expensive. Someone needs to build the system. It needs to treat ore from different locations, so you may not be able to treat all of the ore if it's a single type of system. And the biggest issue I've seen and heard from miners about these systems, about the setup, is that they don't trust that they're getting a fair price for their ore. They like to process themselves because they get their money right away, and also they can see the process and really understand how much gold they're getting out of the rock. They don't necessarily believe that the price paid from these central systems is fair. So a last model that I'll introduce here is a hybrid model where there's a bit of both. There's a bit of upfront processing. The miners either do it themselves or a local service to process the ore originally using ideally gravimetric techniques. That way they can get their gold up front. They don't have the trust issues because they know they're getting what's fair from that ore because they see it processed initially. But then those tailings are available to be purchased by a central system to recover the remaining gold. Again, gravimetric techniques typically in the field recover 30 to 50%, up to 70% if it's a very efficient system. So there's at least going to be 30% of the gold in the tailings following that that's available to be sold to the central system. It's a great source of ore for central systems that can process these lower grade tailings, and it also provides tailings management. The miners would typically leave the tailings on the side of their operation, whereas these central systems would be responsible for managing the tailings that they processed. The cons are that it requires some upfront investment to get the system built in the central location. Regional variation in ore for the tailings can be an issue. And then the real risk is with any cyanide system is the processing of mercury contaminated tailings, which is a worst practice under the Minamata Convention. So it's really important to ensure that upfront processing is producing a mercury-free set of tailings rather than amalgamating with mercury and then sending the tailings to the cyanide plant. So ensuring that there is that separation of processing and the tailings that go to the cyanidation plant are clean and mercury-free is essential. So some lessons learned from technical interventions and designing different systems are that the number one rule is that it has to be economic for the miners. It can't cost them more money to produce their gold. That's number one. Typically, technical interventions can lead to increased recovery. So the miners can get more gold out of their rock, which is obviously a beneficial thing, but that has to outweigh the upfront costs of the system and any additional work that it takes to process their ore. The systems have to be built taking into account the specific sites, the ore and the skills of those workers who are going to use the systems. Maintenance is key. Parts have to be available and the systems need to be maintained. Investment from miners in the systems is an excellent motivator. So if they're investing in these systems, then they're more likely to want to keep them running and to see the benefits of them. Trust building takes time and can be difficult. Pilot systems have been successful in demonstrating that these technologies do work and can lead to improved recoveries, which is a great way to convince miners to switch their practices and invest in these systems. And each site is different. And again, the systems really do need to be tailored to the realities of the sites that we're working with. Okay, so with that, I will stop sharing my screen. Thanks for bearing with me there, and I'm sorry for that technical glitch in the middle there. From here, I would like to turn it over to my colleague, Dominic Bally-Pocro, who is going to provide another presentation. Dominic is a research fellow at the School of Science, the University of Wollongong, and serving as the executive director of the African Center for Environmental Health. He's going to speak to formalization in the ASGM sector and the importance of this in reducing mercury usage, as well as providing a bit more detail on some specific workflows for mercury-free processing. So taking some of the systems I introduced and showing the flows through the various stages of processing to get to a mercury-free gold. So with that, I will turn it over to you, Dominique, to share your screen and to provide your presentation. Thank you.
Thank you so much, Eric. Good afternoon, everyone. And let's go straight. Are you able to see my screen now? Everyone seeing my screen? Yes.
Yes, I can see it. Thank you.
Okay, wonderful. So we are going to discuss on addressing informality in ASGM using microfluid technologies as a solution. And this is now just gone an overview of ASGM, talking about the informality, the cause of mercury environmental contamination, especially. Another slide will talk on just the consequences of ASGM informality, persistence, and under the response to address ASGM informality, we'll discuss the legal and policy response and the technical response where microfluid technologies are introduced, and then the conclusion will come to put an end to our presentation. So coming to the overview of ASGM, we notice that, as you can see, ASGM, artisanal small-scale gold mining, is a labor-intensive, low-technology and mineral extraction processing activity, which is practiced in almost 80 countries in the world, nourishing 45 million of people directly, and indirectly, you can see that we have about 315 million of people which are involved in ASM, which are dependent of ASM. And for what we noticed is like gold is the major commodity which is mined in ASM. And that links us to artisanal small-scale gold mining, which is practiced with several techniques, including mercury amalgamation. And this mercury use makes ASGM the largest anthropogenic source of mercury worldwide. So, coming back to the informality, we can see that informality has its origin under human resources and even economic science disciplines. Under the human resources science, you see that informality concept has been introduced by the anthropologist Kate when it was presented on Ghana's economy in a development context. But when we look at the economic science definitions of informality, we distinguish two approaches. Under the productivist one, we noted that we noticed that informality is associated with a low productivity, the unskilled labor, and a small business size, the low complexity task, and even the quality of jobs. But under its legalist approach, we all notice that informality is about the business or even the worker activity, which is outside the framework of the law. So we notice that most of the time when we are talking about informality, people are considering the legalist approach under the others approach, which I've mentioned earlier. So coming to the cause of informality, especially considering the case of sub-Saharan Africa, we notice that ASM is an inherited practice from the ancestors. When we look at the ancient empires like in Ghana, Soso, Mali, and Songhai empires in the 12th and 13th centuries, ASGM was already practiced in this part of sub-Saharan Africa. But we noted that during the colonial era, dispossessions enter into force where the local population were dispossessed by the colonial government, after which rendered the mineral resources as a state property during the colonial period. So after that period, that situation is still persistent till now, because for now in several countries, the mineral belongs to the government, to the state, and no more to the communities. So that's based on that anthropological foundation, we enter to the root causes of informality in ASGM. One of the major causes is the economic changes and inadequate framing, especially the inadequacy of formalization policies, plans, and programs, which led us to the emergence of informal space for these mining activities, the high cost and bureaucracy in licensing especially, and the inadequate labor and tax regulations. And at that, we can add the corruption and all the institutional quality in the different institutional framework, which is not which is inadequate to several countries. But we also have the mining bias, especially we have the vast areas of land which have been allocated to large scale mines for exploration, which is not even relocated to artisanal miners, when even if these lands are not benefiting to the large scale mines. So at the end, we know this land allocation to large scale mines is detrimental to local miners. And this is another root of informality in ASM. So as a consequence, we notice that ASGM is becoming is performing informal space, especially in places where the law is rarely enforced. And at the end, the heavy labor of footprint of the race for quick profit to ensure subsistence lead to the use of methods that are not very environmental friendly. Considering the case of Cote d'Ivoire, for example, Mercury was introduced around 2002 in Cote d'Ivoire as a means to recover gold from ore. And when we look at also the weak enforcement of mining and even environmental regulations, Mercury used in ASGM has been proliferated and leading to the contamination of the environment. So in terms of response by different governments to that informality and mercury pollution due to ASGM, countries have proposed two sort of responses. We have the legal and policy response, which is which is detailed into the formalization scheme, and the technical response, which is under the Mercury Free Technologies promotion. So when we look at the formalization schemes, these are based on the multilateral environmental agreements domestications, which leads to the incorporation of sub-regional definitional context in national law. Especially we go through what is ASM, what is ASGM, what is what we call about formalization, and how this formalization is understood in different national frameworks. And based on the regional decision, regional agreement, there is an update of institutional, and legal, and political frameworks at national level. One of the key objectives of these formalization schemes are to reduce the licensing challenges, because initially formalization has been seen under has been considered by countries under its legalist approach. So most of ASM groups have been considered informal because they were not licensed. And they were not licensed because of all these challenges that I mentioned earlier. So based on that, countries are working to reduce the licensing challenges under the formalization schemes. But additional steps are taken by also countries to assist ASM groups via the training in the transition from informal to formal status. And after all these, after the formalization schemes have been put into place, now it's time to, we have the legal framework, the institutional framework, and even the policy framework, the political framework which has been established. Now countries are promoting now mercury-free technologies as a technical solution to render efficient this the solution that is presented to address informality in ASM. But these mercury-free technologies, as you presented earlier, have the conditions to be applicable for being successful. And based on what we noticed, the three major conditions for the applicability is to adapt to gold ore type processed by ASGM operators, because we need an adaptation of the type of gold ore which is processed. And we also need to consider the quantities that could be treated or that could be processed by the ASM group, especially. And in ASGM, we put even the artisanal miners, but we also have the medium size or what we call semi-mechanized mining activity according to each country's definitions of what they put in small scale mining. And additionally, we need to also achieve the high gold recovery rates faster than the amalgamation. These are the three conditions that need to be considered when we are trying to develop a mercury-free technology solution. And the literature review on these different technologies, the different mercury-free technologies which are implemented, have been subdivided into three categories. We have the physical metallurgy, the hydrometallurgy, and the pyrometallurgy. So under each type of treatment, we have the different methods that you mentioned earlier, especially the gravity, the flotation, and the cyanide. But we also have the direct smelting, which is also another part of pyrometallurgy. Under the physical metallurgy processes, under the gravity method that you explained earlier, we have the use of sluices, of centrifuge, shaking table, and electroations. But when we look at the process, it all starts with the ore extraction, going to the crushing, the mining. It could be wet or dry, but we advise to use the wet mining just to reduce the dust and all the other health risk associated with the dust. And after the sluicing, where we have that you can see here, we go through the centrifuge, as you detailed earlier, to have a better concentrate. And after concentration, a shaking table is used, washing, and then it's quite easier to separate the gold fine particles with the sand and the other particles. So this is what is used under the gravity method for treatment, especially. But what we are going to see is that after the extraction, what is crucial is to control the crushing and the sluicing, and then the other techniques which are used. And it comes with, when we take, for example, the magnet, the magnetic process, which is used here, the pictures. So you can see that after the centrifugation, where we have a concentrate, and miners proceed to a wet panning, and after the panning, we also have the magnet which is passed over the particles which have been concentrated, and all the ferrous materials are removed, and it remains gold under in the calabash. So this, depending on the ore type, this is quite benefit for alluvial gold, which is when it's mined, because in that process, gold we can the quantities of gold that could be recovered is about 89 to 93%, which could be recovered by miners when they are mining alluvial gold. Going through another physical metallurgical process, we have the flotation process, which is where, as you detailed earlier, where after the mining, all the mined ore is put in the flotation tank, where reagents are added, and after this reagent, where it's maintained into agitations under the flotation mechanism, where we have the foam which is generated. That metallic foam is this is where gold is captured in some bulbs, in the air bulbs or on the reagent, and then these bulbs are dried and gold is quite recovered at the end of the process, after also removing all the ferrous materials too. So in this process, what is key is the reagent type and its association. We have several reagents which are used, generally depending on the type of the rock which is mined, which is the type of ore which is processed. Depends also the reagents which will be used, and what could be done also in the flotation process is the association of different reagents in terms of quantity and the times of contact with gold particles. These are key also to be controlled. Coming to the hydrometallurgy, where we talked about the cyanidation, as you detailed earlier also, we need to consider the ore characteristic, especially after the crushing and the mining, to be sure that depending on the type of ore that we are mining, it could be an oxidized ore or a sulfuric ore, we will consider the type of lixiviant that could be used. But we see that after the mining or the concentration, we go through the to the leaching, and the leaching agent could be depends. It depends. We have it could be cyanide, it could be cassava leach, it could be an amino acid. But the role here is to have something chemicals which will dissolve both gold and all the other particles in the ore. So at the end of this process, we have an adsorption process. It could be copper, it could be carbon, it could be zinc, which we collect all the gold, and after elution and electrowinning, we go straight to the smelting to recover the gold. Key consideration for that, the ore characterization, the preparation of the different particles, especially particle size at the mining stage, is something that need to be controlled, and the flotation to concentrate all the oxidized and sulfide mineral containing gold. And the other parameters such as temperature, the pH, the cyanide concentration, and even the oxygen flows and the absorption time are also parameters that need to be controlled into this process. And as Eric mentioned earlier, these are points which these processes are quite sophisticated and needs trained staff to work on this process. Continue. So, and now we go to the pyrometallurgy process, where we have the direct smelting with the borax, where after we have the concentrate, there is the panning process which is developed, and after the gold is panned, we go straight adding the borax, which is sodium carbonate flour and silica and even some soda ash, just to reduce the smelting temperature. And after that, when you proceed to the direct smelting, you have your gold doré, which appears at the end of the process. It's just a single step recovery, a gold recovery, which is 10 to 30% faster than amalgamation with even a double yield recovery. without mercury use. And in that process, we need to consider the composition of gold concentrates also. We consider the time, the temperature, and the flux addition. And also we need to consider the sulfide concentration in gold, which should be less than 10%. In this process, there is a studies recovered represented that we had about 80% recovery at 1,250 degrees centigrade, and then 90 minutes and a concentrate of flux, which means if you have about two quantities or two parts of all the flux, like which I mentioned earlier, sodium carbonate, the fluoride, the borax, and the soda, all these small chemicals that you have to add in the mix in the proportion of in 2 portions for 1% of gold ore, you will reach about 80% of gold recovery under the borax method. Next step. So finally, what do we retain from all what we said? We noted that informality is rooted in the existing with that. Okay. Informality is rooted in its historical and anthropological foundations. And we have the economic changes and inadequate framing, which led also to raise the informality process. The inadequacy of formalization policies, plans, and programs are additional causes of informality in several sub-Saharan African countries or other developing countries. And to respond to informality and mercury pollutions from ASM, the different governments have proposed a review of the policy, the legal and institutional framework to implement, which are implemented. This review is implemented under formalization programs. And we also noted the development of pilot units implementing mercury-free processes and the technical solutions, which are another way to promote mercury-free technologies in order to abate mercury contamination from ESGM. And what we notice also is that we have existing mercury-free technologies which are proven, depending on the old on the ore characterization, the ore preparation prior treatment, and the technology costs. And we also have the implementation of mercury-free technologies, which also need to be contextualized and dependent on the legal framework in each country. There are some equipment which are authorized or not. So depending on how countries define ASGM according to the legal framework, what they consider as artisanal or small-scale mines, some equipment could be used or not. And depends on that also, miners will customize the type of treatment plants, and based on that, they will need there are some equipment they can afford or they are allowed to use. But what we notice is that there is a need for a synergy of action among even donor agencies, governments, industry, academia, and NGOs to promote mercury-free technologies and render it acceptable to artisanal miners. I think that's for now. What we notice is like ASGM remains a driver of sustainable development when it's formalized and implemented mercury-free. That's my take-home message, and I thank you already for your kind attention. Thank you.
Thank you, Dominic. Really appreciate that presentation. Yeah, it's great to get a bit of background on the formalization, the reasons for the informality and steps to improving formalization, and to dive a bit deeper into some of the specific processing workflows that can lead us to the production of mercury-free gold. So thank you for that very helpful and informative presentation. From here, we're going to move into the discussion portion of the webinar. I am going to introduce a few colleagues here. I'd like to start by introducing both Ms. Bafrina Igulu and Dr. Stephen Bose O'Reilly. Ms. Igulu is the EHPMP Tanzania Project Coordinator with the National Environment Management Council Tanzania, and has been instrumental in the implementation of Tanzania's National Action Plan on artisanal and small-scale gold mining. Dr. Stephan Bose-O'Reilly is a pediatrician with expertise in ASGM and health. He works at the Institute and Clinic of Occupational, Social, and Environmental Medicine, leading the Unit for Global Environmental Health at the University Hospital of Munich. So they will form a panel. I'll turn it over to each of them to take about 5 minutes to talk to what they heard and then to provide some insights from their experience. Bafrina, we'd like to start with you. Could you please comment on what you heard in both Dominic and my presentations and provide any insights on formalization, mercury reduction efforts that have been done to date, and your experience using technologies and technical changes in Tanzania. So please, over to you for about 5 minutes. Thank you.
Yeah, thank you, Eric. But also thank you, Dominic, for such a great presentation. It is just an honor for us to share what Tanzania has done. So looking into small-scale mining activity, actually Tanzania is quite growing fast in small-scale mining. Last year, we had about 10% of the GDP was coming from the mining sector. And we have mining activity that are spread all over the countries. When we started the project in 2020, we had about 1.2 million people. But by 2025, which is last year, the small-scale miners were about 6 million. So you can see how fast the sector is growing. And we also have about 7.2 million people, which also depend on the sector for their livelihood. So that makes about over 10% of the population depending on the small-scale activities. Yeah. So mercury has been in use since the traditional way of mining. So it has been there since the beginning of mining, and through this Minamata Convention, that's why we are trying as a nation to reduce the use of mercury. So we have been implementing our national action plan for reduction of mercury that is in line with Article 7 of the Minamata Convention. And with that national action plan, it just requires us to reduce about 30% of the mercury by 2025, which we have achieved so far. And when we did our baseline in 2020, we had about 18 to 24 metric ton of mercury that was being used annually. But last year in 2025, we also did another study to see how far we have achieved. And we found that we have reduced mercury to 18 tons per year, which is quite significant given that the number of miners increased significantly. So what have we done so far? We are lucky that what you presented, Eric, of about wall or amalgam, it is not something that is being practiced in Tanzania. So what is being practiced is concentration, then going through amalgamation. And when we started this program in 2020, we had about 3 centers that were processing using cyanidation. So that was the method which was being in practice. And because we wanted it to achieve the mercury reduction, because one of the key activities and key pillar of the project was to introduce alternative technology for gold recovery among the small-scale miners. And we started with the initiation of just mapping around to see what are the technologies that are in place and how are they being adapted, and what is the challenge for not being able to move into mercury-free technologies. So with that, when we did the mapping, we came up with 3 technologies that were placed and being used. The concentration method, we had plenty of in Victoria progress in the unfortunately they were not being used because due to lack of awareness among miners. But also we have specific was mainly used in the southern part of Tanzania, and this it can be adapted mainly due to the high energy demand. So it means only at least in the middle scale, who can afford high production, are able to adapt the smoothing method. So the technology that was recommended by miners was cyanidation method. And this involved also ensuring that we move into CIPs and CIL, carbon in pulp, carbon in leachings. And through the project.
Frina, sorry to interrupt there, but on my side at least, your microphone is cutting a little bit. I'm not sure if others are having that issue, but if so, if it's a connection thing, it might be easiest to turn off video or maybe keep trying, and if it persists, I'll let you know.
So let me just turn off the video.
Yeah, I'll do mine too in case.
Oh. Yeah. So let me turn off the video. So can you hear me now?
Yeah, that's much better on my side. Thank you.
Yeah. Okay. So I was saying that we had 3 methods that were highly recommended by miners. And one of them was the concentration method. As I said, most of them were being introduced by various projects which have taken place on the past, and somehow they were not in use, mainly maybe due to lack of awareness, but also we had smelting, which is being used highly in the southern part because it supports the ore type that is available in that area, but also somehow the technology was not being adapted, mainly because of the high demand of energy. So making it look like kind of expensive. And most of the miners were recommending that we should move to the cyanidation technology. So that is the direction that the country has been taken, and through the market itself, we have a lot of intervention that has taken place, and now we're kind of adapting. When we started this project, we had about 3 centers that were serving small-scale miners with the CIP, CIL technologies, and we also have plenty of the VAT reaching, but through the project, we had a number of interventions, and one of them was capacity building, where we collected most of the miners with potential move and to invest on those technologies and try to educate them on how the technologies are working, but also on where they can access the technology. And that went hand in hand with the training of the local technician, because it was our understanding that for this technology to be able to be adapted, our local manufacturers should be able to make the technology available. So we had academic institutions, but also we had our small-scale industry organization, which was leading, and we built the capacity of some locals who are currently the pioneer in constructing of the technologies within. And apart from that, also, it was recommended by miners that for them to be able to be able and assured that they can invest on the alternative technologies, because it is expensive. They needed a lot to know about their geological information. So we had pilot in some of the areas, at least for small scale miner, to know their geological information, but also that went hand in hand with enhancing capacity of our geological institute to be able to efficiently conduct geological investigation for the miners, which means that we had to ensure that they are well equipped. So with that, from where we started the project to now, I said we had about 3, but now we have 50 plus leaching plants. That is CIP or CIL technology, and the market so far is we have what Eric you presented, but also we are calling it like a shared mercury-free processing technology, where an investor is investing and people are coming in just for service, and then they pay. That is the approach which Tanzania is taking. And maybe I should also talk about the barrier. One of the challenges that the technology is not spreading that fast is this technology is requiring a lot of energy, and we still have a challenge in energy in the areas where these technologies are required to be constructed, especially since most of the mining activity are taking place in really, really rural areas. So with that, I can say that the moving toward the mercury-free technology requires a lot of collaboration, but also requires a lot of activity that should go in hand together. Otherwise, as Tanzanian, we can see that we are moving in that direction. So thank you, Eric.
Thank you, Bafrina. That's
you, Eric.
I really appreciate your insights from your experience in Tanzania. It's great to hear that the miners bought in and that the cyanide option has been working. And I think it's really key, as you talked about the formalization and working collaboratively with the miners to train them. So that's a really great example. And thank you very much for sharing your experience. I am now going to turn it over to Stefan Bose-O'Reilly for his thoughts and some perspective based on his experience in ASGM and health, both human and environmental health. Yeah, so Stefan, if you'd like to take the floor for about 5 minutes here to speak to your own experiences and insights on mercury reduction and the benefits for human and health and environmental health. Thank you.
Thank you very much, Eric, and thank you, Frank, Dominic, and Bafrina for all your presentations. I like to hear them all. And I learned a lot. You've given us a clear picture of the technical landscape, mercury-free processing methods, capture technologies, formalization framework, and so on. What I like to do is bring in the health perspective on this, because these technology solutions matter. But I need to flag down some considerations that we might need to take into consideration if we want to implement them. So the urgency is a clinical one, not just only an environmental one. That's what I want to talk about. We all understand that mercury is dangerous. In the communities where ASGM takes place, we see pregnant women with mercury burdens sufficient to cause fetal neurodevelopmental harm, like a study in Tanzania showed. We see children with IQ deficits, with impaired memory, language problems, and that will follow them for the rest of their life. We see workers with neurological disorders, kidney dysfunctions, and the workers cannot even connect these symptoms with their occupation because nobody has told them. No physician knows about mercury as a poisonous disease. The technical solutions offered today are not abstract. They make the difference between a child born healthy, so mercury-free, and a child born with permanent neurological damage. So this is why these two presentations were so urgent and important, and why this needs to be implemented. But I want to make a point that it's not only mercury. Mercury is, of course, the focus of the Minamata Convention, and of course, for a very good reason. But mining and processing is releasing other toxic metals that also harm. Lead, for example, is released in many gold-bearing ores together with the gold, and this lead is exposing people as well. And lead is a very potent neurotoxicant, especially with no safe threshold for children. And arsenic is co-occurring, for example, in gold in many geological settings. And arsenic, for example, can cause cancer as well, cardiovascular disease, and so on, skin problems. And if we only focus on mercury, like retort, for example, is only eliminating mercury, then we don't get the full picture, because the people will be still exposed to these other toxic metals. The processing is of course, very hazardous beyond the chemistry. I mean, of course, the inhalation of vapor is the key point for mercury, but as well, and the processing areas, it's extremely dusty, and dust can cause silicosis, which is a very severe lung disease. And then these machines are extremely noisy, causing hearing loss. Noise can cause many other diseases like sleeplessness and cardiovascular disease and so on, and people are not protected. But if you ask the miners what's their main problem, they say it's the accidents. And you showed very clearly these pits and tunnels and so on. But they can collapse, and the miners are buried alive in them. And there is a lot of child workers as well in these tunnels, especially if they're very small tunnels. The equipment they use is very dangerous. They face a lot of injuries, and these are common, but they're not well reported. And in many ASGM sites, there is no emergency response capacity. There's no healthcare center, nothing. And a serious injury means hours of travel to a facility that may lack the capacity to treat it. So the technical solutions should address these hazards together with the chemical exposures. So like dust suppression, hearing protection, machine guarding, basic first aid capacity. It's not a luxury. This is a part of what makes mining safer, and miners would accept more technical solutions if they see the immediate benefit for themselves. Then we talked about cyanide. You know, cyanide is a very toxic chemical as well. Acute toxic, you die immediately. So we need to see if the handling of cyanide is safe or not safe. And cyanide can cause rapid death, and there is a huge lack of data different to mercury from ASGM if there were any accidents with cyanides or not. There are some stories that cyanide did cause some damage, but most people say, no, we never heard about cyanide as a toxic substance and it didn't cause any damage, but we have not the data for this. So the message is not that we should avoid cyanide. If it's managed safely, it's you know, as you explained, it extracts by far more gold from the ore. But the message is that the transition from mercury to cyanide must be accompanied by training, proper equipment, containment infrastructure, and emergency response protocols. I mean, Befrina would be the excellent person to speak about cyanide because she showed me one of these cyanide hangs in her own country in Ramagasa, which was very impressive. So if we're not careful about cyanide, we trade one chronic poison for another one. The technical solutions must include accident prevention, because this is the point that the miners see themselves, that this is dangerous. They don't smell mercury, they don't feel mercury, they don't feel lead and arsenic, but they see the accidents. So what should be included in a wider perspective, from a health perspective, should be personal protective equipment, of course, engineering controls, safe work practices, emergency response capacity, and then a very simple solution is the separation of housing and working, so that this toxic mercury vapor is not exposing, for example, pregnant women, breastfeeding women, or children. And pregnant women and breastfeeding women should not be working anyway as small-scale miners. And there should be no gold shops in the villages. So because, you know, if you separate, it's cheap and it's effective. Access to healthcare remains a critical gap. So we need the infrastructure for healthcare in these national projects, in these, so not focusing only on a chemical substance, but on improving a system. The workers usually do not have occupational or even general health services. They do not have baseline health assessments. When they develop symptoms, for example, a tremor or cough or skin lesions, there is no pathway to diagnose or treat. And even if they reach a health facility, the doctors there might not recognize occupational or environmental etiology, since they're not even trained for this. So the technical solutions in the mining sector must be paired with strengthened health care systems in the mining regions. This means training healthcare providers to recognize mercury and lead toxicity. It means establishing referral pathways for suspected cases, and it means integrating occupational health into primary healthcare, even in the informal sector. Final practical point, we cannot manage what we cannot measure. So we usually don't have any lab capacity in mining areas or even in countries where ASGM is common. So to analyze mercury in human specimens like urine or blood, you need the lab capacity, and you need to build up this lab capacity. And at this stage, it's very limited across sub-Saharan Africa. And building regional lab capacity for mercury and other toxic metals like arsenic or lead should be a priority. This serves multiple purposes. It enables program evaluation, it supports clinical diagnosis, and it generates local data that you need to evaluate the efficiency of your programs. And the same is with environmental monitoring, and there is not much of a difference between human and environmental monitoring. So we need more lab capacity in the country. The technical solutions we have just discussed today, mercury-free processing, are essential. They represent real progress. I see the progress. But they will deliver their full health benefit only if we implement them with a health lens. So that means addressing not only mercury, but lead, arsenic, dust, noise, cyanide. It means it means that we need to focus on accident prevention and emergency response. It means strengthening healthcare access for mining communities, and it means building the laboratory infrastructure to monitor exposures and evaluate progress. The goal is not only cleaner mining, the goal is healthier communities, fewer children with developmental delays, fewer workers with chronic diseases, and fewer families that lost a young man working in these mines. The technical solutions are the means. The health is the end. Thank you.
And really appreciate those insights on health, both focused on mercury as well as the sort of broader potential impacts of artisanal mining. So I think now we'll take a few more minutes. We're running a bit late, but we'll spend about 10 minutes here to do a question and answer, if everyone is all right with that. Thank you all for the questions. Please keep those coming in. We can add questions into the chat, and I will scroll through now and work my way down and try and answer some of the questions that we have here in the chat. So I'll start. The first question I see here, and actually I'll go up to the top to make sure I don't miss any. Okay. Okay. Okay, sorry, question for Mr. Dominique. Why is Jinshan mentioned under mercury-free technology, and is there data available at Jinshan? Dominique, are you able to comment quickly on that question?
Thank you so much. I'm even trying to respond to that question now. Just to say that the Jinshan process is mentioned in under mercury-free technologies, in the sense where it's in this process, there is a new leaching agent which has been developed, because the conventional leaching agent that we know in cyanidation is a sodium cyanide. But through the Jinshan technology, they developed a new leaching agent. So I wanted to give them the details on this agent. Some papers have been developed on that, and I can even share the links with them if they want, so that they will go through the study and see which leaching agent have been developed. This Jinshan technology. I'll put the response in the chat.
Okay, great. Thank you. Thank you, Dominique. There's another question I see about cost-benefit analysis of alternatives. Yes, I think that is definitely a consideration. I can just quickly speak to that. Understanding the costs of the system and the associated reductions that you would get from them, as well as the available financing of the mining groups that we're supporting, is definitely a consideration of the selected technologies. Of course, the budget is the primary thing that constrains what we can work with, but also the amount of mercury reduced or expected to be reduced from the different technologies, as well as the potential increases in gold recovery, are key factors in determining what processing workflows to consider. There's another question here about how are health and environmental benefits from reduced mercury use being monitored in ASGM projects or operations, and what indicators have been most practical at the community level. I might turn this one over to Berfina to speak to any examples she has from the work in Tanzania about how they've been monitoring the outcomes of the National Action Plan interventions on health, both human and environmental.
Yeah, thank you, Eric. So under the project, we currently don't have indicator which is direct to measuring how the environmental benefits, but under the National Action Plan, we're actually measuring it. And what we did initially, we had health assessment, but also environmental assessment. And now we are looking, we had health assessment in terms of how much people are being affected, and number of the cases that are being reported in different hospitals. And after some time, we are now we are in evaluation of our National Action Plan. We're also trying to check if the cases are reducing or they're still continuing. But you understand that mercury exposure is something that is taking a really long time. So you might not be having like a direct impact now, which is not easy to be measured because some cases may be long-time exposures and they're just being manifesting now. So that is a challenge now. But with regard to the environmental benefit, we can still measure it with regard to the ecosystem, like how much of the ecosystem are we being able to restore, but also save from being affected with the reduction of the mercury use? Yeah, so that is our approach on the program, also nationwide.
Thank you. Yes, thank you, Berfina. Okay, we'll keep moving. We've only got a few more minutes here. I see we have one hand up. Kutala, have you got a question that you'd? Sorry about that, I was on mute. We've got a few more minutes here. I see that there's one hand up. Kutala, would you like to unmute yourself and ask your question? Oh, it seems maybe microphones are blocked. Sorry. I'll go back to one more question here then that came in the Q&A. The question was, introducing a range of chemicals, silica, lead, flocculants, how will these be managed by informal sector? Should formal interface be established so that part of the process must be declared formally in terms of policy? For example, we need to avoid environmental and occupational chemical exposure as witnessed in the agrichemicals and agricultural sector. So for this one, I guess talking a bit about the interface between formal and informal sectors and managing the health impacts, I may turn this one over to Stefan if you're comfortable speaking briefly to how the interface between the formal and informal sector can work and how we can address the gap there to improve health outcomes.
I must admit, I'm a pediatrician. And if a family would approach me and say they have a problem with a child in a mining area, I would not ask them if they're formal or informal. I would be a bit frightened if they're illegal and would come in with a gun. Yeah. But I think the healthcare sector needs to take care of people, whether they're formal or informal. And people, for example, a good example is in Ghana, a project the World Bank is involved. They changed to mercury-free mining, but at the same time, the company, it's not a big company, it's maybe around 100 people. As a benefit, all these miners can use the local healthcare services for free. So I think this is a good example how you could work, and especially if miners organize themselves, and even informal miners have organizations like miners associations. If they make a deal with the local healthcare center, then this is very beneficial. Or for example, in Tanzania, the large-scale mine is paying for the hospital in Gate, or did pay for a long time. So even if large scale comes in and gives as a benefit of the huge benefits they make from gold, price of gold is incredibly high. into healthcare center, this is okay. I think the other issue is if a mining inspector comes into an informal mining area, he is not welcome very much. If the government Ministry of Health sends a midwife into the area and a few nurses to build up healthcare centers, they're most welcome. So I think the healthcare is an opportunity to overcome this issue that informal miners are difficult to address because they're pretty shy because they are informal. So if you use midwives, nurses, people that miners trust very well, and especially women trust, and women are the main changing potential for these areas, then you're doing a good thing. I did not answer your question, but I made a point.
No,
Sorry.
that's
Yeah.
great. Sorry, go ahead.
Maybe, Eric,
Sure.
I can also contribute on that.
Perfect.
In case
Thank you.
of Tanzania, with us, we have two different arms. In the mining perspective, you might be having someone being recognized as informal by not being direct licensed. But we also have another agency which is dealing with chemicals. As long as you are a chemical user, you are being registered. So for them, it doesn't matter whether you have a mining license or you don't have. But as long as you are in contact with chemical, you are being registered and you should be able to meet the minimum requirement for using that chemical. So that is how it's happening in Tanzania. In that way, we have a registry of people who are using chemicals, but also we ensure that they are well trained on the use of that chemical and they know the effect that it is coming with it. Yeah, thank you.
Great. Thank you, Befrain, for that addition. Okay, I think we'll take one last question here. We'll try Kutala again. Please unmute your microphone now if you're able and go ahead with your question.
Oh, yeah, thank you very much. I hope I'm audible. My name is Chuhla Chwayo. I am from South Africa. I am the national spokesperson for the National Association of Artisanal Miners. And thank you very much for all this presentation. I think the presenters really did an amazing job. Ours is just simple. We just are part and parcel as well as NAM of our national action plan here in South Africa that we are doing under the Minamata convention with the FFE, Africa Institute, and other stakeholders. Our interest is that we have seen some of the pilots and the projects that were highlighted by some of the speakers and the panelists, and we are interested as the people from South Africa because we are at the time where the Mineral Petroleum Development Resources Act was just is being amended to include for the first time artisanal and small scale mining, which is a plus for us as an association because we've been advocating for the formalization and integration of the ASM into the main economy. So ours is to how do we participate with UNITA into piloting some of the projects and the alternatives, especially to mercury use, because it is something that we want to champion and we want to also demonstrate as artisanal miners and NAM that we are for the change and we want to have alternative instead of putting a barrier, instead of putting a solution to a challenge that our people are facing. Thank you very much, Program Director.
Oh, thank you for that intervention. That's great. I'm glad to hear that it's being considered, that it's working into the laws, and that you're taking steps to try and move forward with some of these intervention projects. I'll just quickly note that there are some other good examples of projects in other countries that have been doing this work under the Planet Gold project. So that might be a good place to look for examples that you could take from on that. But with that, I'll wrap up the Q&A. Again, thank you very much to all the presenters, the panelists. Thank you everyone for attending and for your questions. We really appreciate the discussion. And now I will turn it over to Oliver to wrap it up. Thank you, everyone.
Thank you very much, Eric. And thanks to everyone who joined. Very much appreciate you you registering for this webinar today. We do apologize for some of the issues and apologize for the French interpretation. We were working away in the background but couldn't get that to work today. We'll try and fix that for future webinars. Talking of which, it was mentioned earlier by Frank, but we will have a UPOPs and e-waste webinar on the 15th of April. Communications on that will go out next week, so please keep an eye out and register if you would like to join. So just once again, thanks to Eric for moderating. Thanks to all of our presenters and discussants. It's a very interesting topic. It's great to be able to share different perspectives, different experiences going on, and we hope that you enjoyed it and can dive deeper. I already see some people trying to connect and understand a bit more on this. So thank you very much. Thanks to all. Enjoy the rest of your days wherever you are, and we hope to see you soon on one of our upcoming webinars. Thank you all.